Hello everyone, we are Group 6 and today we are presenting our project titled Cloud-Based Student Management System. Our project focuses on developing a centralized and scalable student management platform using Google Cloud technologies. The system is designed to simplify the management of student records, attendance, marks, file storage, and analytics through a cloud-based solution. The team members involved in the projects are Nandana Ranjit, Putta Grishmita Sai, and Varun Chaitanya. The project is aligned with Sustainable Development Goal 9, which focuses on innovation and infrastructure by utilizing modern cloud technologies to improve efficiency and accessibility in education management systems. Now, let us begin with the problem statement and objectives of our project. Now, coming to the problem statement and objectives of our project, in many education institutions, student records are still managed using manual or paper-based systems. These traditional methods create several challenges such as difficulty in maintaining records, lack of real-time access, and inefficient communication between departments. There is also a no proper system to identify at-risk students, which is early based on attendance or academic performance. Because data is often stored separately across departments, it becomes difficult to track overall student progress and generate meaningful insights. To address these problems, our objective was to build a centralized cloud-based student management system using Google Cloud technologies. Our system aims to centralize student data on cloud, provide secure real-time access for faculty and administrators, use analytics to identify at-risk students early, create interactive dashboards using Looker Studio, deploy a scalable backend using Cloud Run overall. The goal of this project is to improve efficiency, accessibility, and data-driven decision-making in education management system. This project is also aligned with UN SDG 4 for quality education and SDG 9 for innovation and infrastructure. Now I will explain system architecture of our project and how all the components are connected. Our system is mainly divided into three parts: front-end, back-end, and Google Cloud Services. Starting with the front-end, we used React.js to build the user interface. The front-end includes login page, add student form, file upload features, dashboard view. This provides a simple and interactive experience for users. Next is the backend, which is developed using Flask in Python. The backend acts as a bridge between the frontend and the Google Cloud Services. The backend handles REST APIs for communication, authentication, and middleware for secure access. Data validation before storage, file handling during uploads. Finally, we integrated multiple Google Cloud services. We used BigQuery to store structured student data such as marks and attendance, cloud storage to store upload PDFs and documents, Looker Studio to generate analytic dashboards and visual representations, Cloud Run to deploy the Flask backend as a scalable cloud service. So overall, the frontend sends a request to the Flask backend, and the backend processes the requests and interacts with the Google Cloud services to store and retrieve data. Now, I will explain the main features of our application. The first feature is secure login. Our system provides authentication protected access so that only authorized admins and faculty members can access the portal securely. The second feature is Add Student. Users can enter student details such as name, marks, and attendance through the front-end form, and this data is directly stored in BigQuery. Next is File Upload. The system allows users to upload PDFs, mark sheets, and reports, which are securely stored in Google Cloud Storage. Another important feature is the dashboard view. Users can easily navigate through the system and view student-related information from a centralized dashboard. We also integrated Looker Analytics. This helps generate live visualizations such as attendance trends, marks distribution charts for better analysis and decision-making. Finally, the application is cloud deployed. Our Flask backend is deployed using Google Cloud Run and making the application scalable and accessible from anywhere through the internet. These features together make the system efficient, centralized, and user-friendly.
Let's dive into the technical engine powering our application. When we designed this system, we knew that scalability and reliability were non-negotiable. That is why our entire architecture is built on four core Google Cloud components. Uh, First is BigQuery, which serves as our cloud data warehouse. We choose BigQuery because traditional databases can bottleneck as student populations grow. BigQuery stores all of our structured student data such as their unique IDs, names, daily attendance records, and exam marks. Because it is a serverless warehouse, it enables us to run incredibly fast SQL queries across massive datasets without any lag. However, not all educational data is neatly structured into rows and columns. That is why we utilize cloud storage as our second component. This acts as our uh, file storage bucket. So whenever faculty member uploads unstructured files like PDF, reports, scanned mark sheets, or assigned upload, then they are securely routed here. This separation of structured and unstructured data ensures our system remains highly reliable and scalable. So third, we have Looker Studio. So Looker Studio it connects directly to the BigQuery to generate interactive dashboards. This gives administrator a live look at attendance charts and marks trends and deep class level analytics. So finally, trying all of this together is Cloud Run. We didn't want the hassle of provisioning and maintaining virtual machines. So Cloud Run provides serverless deployment. It takes our Flask backend, deploys it as a containerized service, and automatically scales up when traffic spikes, and ensuring the app is always publicly accessible and responsive. So coming to the live demo flow to show you how these cloud components interact in real time. Uh, Let me walk you through our live demo flow. This entire journey takes just 2 to 3 minutes to execute. Like it starts at step one, where the user launches the application via their browser to open the React frontend. And step two, the system security kicks in. The faculty member must enter their credentials to securely log in once verified. The access is granted. Immediately in step three, they can navigate to add student. Here, they submit a form containing new student metrics, and the data is instantly stored in BigQuery. To prove this isn't just a front-end magic, step 4 involves us opening the GCP console to verify BigQuery, showing you that the database table has updated live. So the second half of the demo test of our file routing is done here. So in step 5, the user uploads a PDF document through the interface, which is routed directly to the cloud storage. In step 6, we verify this storage by showing the file instantly listed in the GCP bucket console. Step 7 is where the insights happen. Uh, we'll open the Looker dashboards to show how those new attendance and marks inputs have dynamically updated the live charts. So finally, in step 8, we showcase the Cloud Run URL demonstrating our deployed backend securely handling the API response. So coming to the team roles and responsibilities, building a seamless flow from a React frontend all the way to Google Cloud Warehouse required a strict divide. and conquer approach. So here is how we distributed our team roles and responsibilities. Nandana Rinjit took charge as our front-end developer. I'm gonna build the entire React.js UI setup. She was responsible for creating the secure login page, the interactive dashboard page, and the functional components like the add student form and upload file UI. Most importantly, she wrote the logic to connect this beautiful front end seamlessly to our backend APIs. The backend itself was architected by Grishmita, our backend and cloud lead. So she wrote the Python Flask backend logic, specifically coding the APIs that route add student data to BigQuery and files uploads to cloud storage. And she also designed the BigQuery table schemas and handled the rigorous API testing and data validation. And finally, Varun Chaitanya, it's me, managed our dashboard and deployment. I handled the complex Google Cloud setup, configuring the APIs and IAM security permissions. Uh, like I established the connections for our BigQuery and the storage buckets, designed the visual Looker Studio dashboards, and successfully executed the final cloud run deployment. I also oversaw our final integration testing to ensure everything worked perfectly together. Thank you.
Hello everyone, I am Grishmita. Now I will explain the backend code of a project. We developed the backend using Flask in Python. In this code, we import Flask and Google Cloud libraries, configure BigQuery and cloud storage, initialize backend clients, and create a simple AI risk calculation based on attendance and marks. Student Add Student API. Here, we implemented the Add Student API. This API receives the student details from the front end, such as student ID, name, attendance, and marks. The backend validates the data, calculates the student risk level, and scores everything into BigQuery. Upload file API. This section shows the upload file API. The backend receives the files from the front end and uploads them into Google Cloud Storage. We also generate a unique file name using timestamps to avoid duplication. Service account.json. This file contains the Google Cloud Service account credentials. It allows our Flask backend to securely connect with BigQuery cloud storage, other Google Cloud services. This provides secure authentication between our application and Google Cloud. To conclude, our project successfully demonstrates a cloud-based student management system using modern Google Cloud technologies. Our system includes React frontend with login, add student, upload file, and dashboard features. Flask backend connected with BigQuery and cloud storage. Looker Studio dashboards for attendance and mark analysis. Analytics deployment using Google Cloud Run. This project helps improve centralized data management, accessibility, scalability, analytics in educational institutions. Thank you for listening. Hi, our project is student management system built using a full stack architecture. We have used React for frontend and Flask for backend and integrated multiple Google Cloud services. This is a deployed application which is fully hosted on Google Cloud Run. This is the login interface where users can securely access the system. We have designed it with a modern UI for better user experience. This is the dashboard where students can navigate to different features like performance, tracking, assignment uploads, and analytics. Here, users can upload assignments. When we upload a file, it is sent to the backend API and stored in a Google Cloud storage. As you can see, the file is uploaded successfully and stored in the cloud. This section displays the student performance, including marks, attendance, along with a risk indicator generated using a simple logic. For analytics, we have integrated Looker Studio, which visualizes the data stored in BigQuery. This provides real-time insights into student performance. We have used multiple cloud components, including Cloud Run for deployment, Cloud Storage for file handling, BigQuery for data storage, and Looker Studio for visualization. So overall, our system demonstrates a complete cloud-based full stack solution for managing student data efficiently. Thank you.